population size and abiotic factors. Which abiotic factors affect population size and how? So the abiotic factors that most commonly affect the population size are temperature, light, pH, that's wrong, water and humidity. So as a little acronym, you can remember tall ladies prefer water. Temperature, light, pH, water and humidity. So temperature. So each species has a different optimum temperature, and the further away from the optimum, the smaller the population that can be supported. In plants and cold-blooded animals, as the temperature falls below the optimum, the enzymes work slower and the metabolic rate reduces. Therefore, the populations will grow slower. At temperatures above the optimum, the enzymes work less efficiently because they might denature. Therefore, the population grows slower. Warm-blooded birds and mammals can maintain constant body temperature regardless of their external temperature. So if it's really cold outside, we can do things like shivering, which will make us warm up. But the further away the temperature is from the optimum, the more energy these organisms use to maintain their normal body temperature, which means there's less energy for growth, and so they mature slower, and therefore the reproductive rate will be slower, and therefore the population size will be smaller. Light. So light is a source of energy for ecosystems, and the rate of photosynthesis increases as the light intensity increases. And the greater the rate of photosynthesis, the faster the plants will grow, and therefore the more seeds that they produce, and their population growth and size therefore be greater. And that means that the populations of animals that feed on the plants will also be larger. pH affects enzyme action. So each enzyme has an optimum pH, and a population of organisms is larger when the suitable pH exists, and it will be smaller when the pH is different from the optimum. Water and humidity. Where the water is quite scarce in a population, it will be small. The population will be small, and it will consist only of those species that are actually adapted to living in dry conditions. And because humidity affects the transpiration rates in plants and the evaporation of water from animals, in drier air populations of species adapted to tolerate low humidity, it will be larger than those without those adaptations.